now it is, so this is the fact. The fact is that in an aircraft investigation, a team from Boeing will either already be on the way, I'm assuming they're on the way, or will soon be on the way, because the decoding of the black box, which is the flight data recorder, will have to be done by Boeing. Okay, so they will have to anyway come and assist with the investigation. They will also have a history of this aircraft, where the various parts of it, components of it, were manufactured. That data will have to now be examined both by them and by us, and a very deep seated examination will have to take place, because let me take you through Charki Dadri, okay, 996. That was a mid-air collision. The cause of the accident, which led to 360 people dying, was immediately known. Now, why the ATC did what they did, why the pilots were not aware, protocol issues, but the reason for the crash was immediately known. In Mangalore, for example, we knew that the plane overshot the runway, that this was a tabletop airport, and the plane simply could not stop in time. That is not the case in Ahmedabad. It's a 3.5 kilometer long runway, more than enough, sufficient for this plane to have taken off. It's a relatively new plane. Planes can last for 30-40 years. This was procured by Air India in the last 10. The entire fleet is about 10 years old. It is not known to have, this variant of the Boeing aircraft is not known to have other fatal crashes. But the decoding of the black box will have to be done by the team of Boeing, which I'm assuming is already on its way, and if it's not, will have to be on its way very shortly. So, Squadron Leader Mitroo joining me in the studio now. I just want to take a pause for the cause, and if we can, just go through the sequence of what we can see. There's stuff that we don't know, there's stuff that now nobody knows. Okay? Very unlikely even the pilots knew exactly what was going wrong as they were fighting it. They had 60 seconds when it all went across. So, let's take it sequence by sequence, step by step. I'm going to request my colleague Siddharth to give instructions to the production control room that we're going to do the sequence of events from what we can see, the photographs that have come our way, the information that has come our way, to try to get the best possible estimation. Siddharth, can you help us out? Can we take this sequence on? Is it possible? Can we get the PCR crew to get that started, please? I'll be very grateful, because we've been analyzing this for an extended period of time in bits and pieces. The photographs that largely had to emerge and the visuals that had to emerge are now available with us. So, with the indulgence of Group Captain Mitroo, Squadron Leader Mitroo, sir, let me just take us through perhaps the most important bit of visual evidence, which is a person on the rooftop of his house near the Ahmedabad airport, happened to be there, saw this plane lower than usual, took out his mobile phone and shot, which will now go down in living memory as the last visuals of this aircraft flying. Let me take you through it, sir, as we can. It's a very short clip. It's only about 15-16 seconds. So, let's take you through it. So, this is frame number 1, 16-second clip. Okay, what you see in this frame is clear blue skies. You see a rooftop of a building. Now, let me take you through this. This is the point when the camera moves towards the aircraft. Now, the aircraft on your screens, this is 1 second into the clip. What you can see in this very clearly, that all 3 landing gears in the undercarriage of the aircraft are deployed. You can clearly see the nose gear, it is intact. You can clearly see the left and right landing gear, they are in deployed position and they are both intact. The wings of the aircraft on the left and right to me also look intact. The horizontal stabilizers and vertical stabilizers are intact, and you can clearly see the two engines are attached to the aircraft. Now, whether they were flamed out or not, you can't tell. Obviously, there is no way of telling from this image, but this is, on the face of it, an intact aircraft. You can't see any physical damage on this aircraft at this point of time. As you see this move towards 2 seconds, so between 1 second and 2 seconds, you are seeing that it is in a downward trajectory. So, it is losing altitude very, very rapidly. Okay. Now, what you see a few seconds into this clip, right before the point of crash, before the aircraft disappears into the trees, is that the nose of the aircraft goes up. So, the engines are still attached, the landing gears are deployed and still attached, the horizontal, vertical stabilizers, everything is there. The nose of the aircraft is going up. It would not be unreasonable to assume that till the last second the pilots were trying to pull up and they had some control. Now, what you do not see is the aircraft rotating to the left or the right, going into a nosedive. That is what you do not see. So, clearly the ability to glide or guide the aircraft was still with the pilot. The horizontal, vertical stabilizers were working. I cannot tell whether the flaps were deployed, not deployed, whether they were functional. It's impossible to tell, the image is not high resolution enough, but you can clearly see the horizontal, vertical stabilizers, they are attached to the aircraft, and then the aircraft disappears below the building. It's going down tail first. Okay. So, now at this point of time in this clip, the aircraft has now disappeared tail first below the building line into the horizon. Then you see debris. Have a look at this. Okay. So, you see debris flying off the aircraft, and then you see the explosion, which is the massive fireball that takes place. Okay. So, let me just talk you through this once again, and then let me get Squadron Leader Mitroo to talk us through this. So, here is the aircraft coming. Okay. You are seeing the nose is being pulled up, but is continuously losing altitude. You see debris flying off. It hits tail first, massive fireball. Okay. This is a fully laden 9 hours of fuel in this aircraft here to London, and then there is nothing left. So, between what we can see and what we cannot see, so am I roughly accurate that at least the aircraft from this visual looks physically intact?
Thank you very much for inviting me. I would convey my condolences first to the departed souls in this accident. As we were talking about the attitude of the aircraft just before it disappears behind the buildings, the nose up attitude is not an effort to climb. It is evident that the aircraft has lost power and it's doing a crash landing. This is a landing attitude. If you notice, even normal landing, the main wheels touch down first, the nose wheel is much higher on touchdown, and that is the attitude which we see now, that the pilot has brought the aircraft to a landing attitude. Now, as far as the stabilizers, the vertical and horizontal, the elevator and the rudders are concerned, well, they are in the flying mode. Nothing can be said about it, but I can see on the right side, the right undercarriage, the starboard undercarriage is down, whereas the left may be obscured by the tail section.
It's down. So, let me give you a clearer vision of it, which is right in the first second, right there. So, you can see
I think all the three landing wheels are down. Yes, all the three wheels are down, and the engines, of course, are intact. You see here, what has been, what my understanding to the whole thing is that this is one of the modern aircraft, fully computerized and a fly-by-wire system. Now, this aircraft is capable of climbing up to 15,000 feet on single engine, from zero level, from ground level to 15,000 feet. It can climb even on single engine, fully loaded aircraft. But here, the suspicion is that both the engines have failed, and the pilot has given a mayday call probably 12 seconds before he crashed. That's a very, very critical position.
Okay, so just on face value, and you can see it here, so it'll be easier for both of us.
Yes.
So on face value, from what we can see, it's a limited angle, it's grainy footage, it's taken from a distance, obviously, but it looks intact. You can see the vertical stabilizer, you can see the horizontal stabilizers, you can see both the engines, you can see all three bits of the undercarriage with the landing gear. The wings look intact. I don't see, at least on, as you mentioned, the starboard side, you don't see a gaping hole somewhere. It looks like an intact aircraft. Now, if I take this forward, sir, a little bit, okay, into
you see now this comes the landing attitude.
Yeah, so this is about landing attitude, and to the best that I can tell, right before it clashes, let me take it a few seconds back till about this point. It looks to me, I know this is grainy, but it looks like the flaps are down. Okay. I don't know. It's grainy footage. It could just be that because the footage is a bit grainy. So we can tell Squadron Leader Mitroo that this is not. It's not gone into a nosedive. It hasn't veered to the left or into the right.
It has gone into normal landing attitude.
So he's trying to do a crash landing. That's the best he can do.
He is doing that crash landing. That is visible.
Okay.
And the best part over here, as I was telling you just now, this aircraft is capable of even climbing up to 15,000 feet on single engine with fully loaded aircraft. Now, why is it that both the engine power have failed? This points a finger at the computer's failure.
Okay, could be. So it could be, and we know the 737 MAX has had these problems. Okay, that the aircraft would suddenly go into a nosedive is what's been reported in the air crashes there. This is a different aircraft. Now here it is. Now that's a screenshot. So you can see the undercarriages are intact. The aircraft looks intact. It does not look like it has gone through some sort of explosion or an implosion at this stage. So whatever catastrophic failure is happening, it is not physically visible from this image. Now have a look at the next image on your screens. Okay, here it is. This was what I was trying to show you. The wing spans on both the left and right before the crash. You can clearly see that both the engines are still attached to the aircraft. Okay, so there's been any physical damage that is visible. The wingspan of both the aircraft, sir, looks intact. Now we can't tell the flaps at this point of time whether they're operating or not. There's no way for us to tell.
Sir, it is no doubt that the airframe of the aircraft, entire aircraft, is intact till the point of touchdown, till the point of crash.
Okay, so here's the point. So here's the point from when you can see here it's more level, and then you can see the nose starts going up. And you are saying that's a pilot. Of course, he's coming into landing position.
He is coming to the landing position.
So he's doing the best that he can and hoping for the best that I can. I have the undercarriage, and if we get lucky, only thing I can do is attempt a crash landing because I still have attitude control, but I have no power.
That is there.
Okay.
That is there.
So we have to draw an assumption that he still had some sort of attitude control, but he didn't have any power at all.
Absolutely.
So he's not lost control of the aircraft. It's not an aircraft nose diving or veering to the left.
No, there is no nose diving. It's visible.
Okay. Now this is a part, sir, which has been found, which is a part of one of the wings. Okay. This is the tail section of the aircraft. So this is the horizontal stabilizer with the tail section of the aircraft. Now, of course, a large part of it is damaged. This, I'm assuming, inspection flap at the bottom is open. Now this could be because of the crash.
That happens.
It could be anything.
Impact.
Now this is, I'm assuming, a part of the wing, sir.
That's right. That's right.
So this is a part of the wing which is sheared off. It's hit a two-story structure. This is the entire tail with the horizontal stabilizer also, which has gone into a building. These are not burnt. So it is clearly hit tail first. These sections have got sheared off. And the explosion, and this you can see at the bottom has a wheel also, right here. There's a wheel here.
Okay.
And we'll get a better shot. As you can see over here, this part is a wheel. You can clearly see the strut is
the
there
left
and,
behind. Yes.
and the wheel is there. So this is clearly one part of the rear landing gear, because this is a tail section, this is a wing section, and here you can see the horizontal stabilizer.
That's
Okay,
right. That's right.
right. Here you can see the undercarriage again.
Okay.
So the undercarriage is smashed into this part of the building,
Yes.
and the tail section. So it's gone down like this. The undercarriage is sheared off, and the tail section is sheared off, and here you have it. Here is from inside the building.
That's right.
You can clearly see, and the way this is impacted. So this was a reinforced concrete column. You can clearly see this is not hit with only vertical velocity. It's hit with horizontal velocity.
Yes.
Because it has smashed the reinforced concrete column inside and completely smashed the wall.
That's right.
Okay.
That's right.
One tire is of course exploded, most likely of course in the crash. One tire seems to be intact over here. You can see a secondary tire over here, but this is of course the rear landing gear, or at least one part of the rear landing gear of the aircraft. Okay. It's wedged between two floors.
That's right.
This we've been given to understand is actually the aft fuselage of the aircraft. So now this is painting a picture that it has gone down, tail down, which is what we suspect from the visuals.
Yes. Yes.
The horizontal stabilizer in the tail section have got sheared off. The landing gear, rear landing gear, have also impacted this building. Here they are inside the building. Then the fuselage is literally hit the floor. So half of it is below and half of it is above this roof line.
Yes. Yes.
And it has gone sheared through the floor, but it is tapering towards the end, and I'm assuming this is the Air India logo branding which is happening here.
That's right.
Now if you look at this is from inside. Again, you can see the fuselage sir here.
That's right.
Right. So you can see in the center of your screen here, this is the fuselage. So the bottom end of the fuselage, which would be cargo hold and other things, and the top end of the fuselage is above the roof line.
That's right.
And certain segments of debris have of course flung into the building over here, where you can see the people standing.
That's right.
Okay. Now this is what has happened at the crash site. Okay. So you can see the remaining part of the aircraft with shorn of the tail and the undercarriage, which has gone into the building. This back end of the aircraft, which is, I won't call it intact, but it is recognizable, because the rest of it is now just a charred remain. It's
Yes.
completely unrecognizable. But this you can recognize as the painted in the Air India color back end of the fuselage. Now this is the airport, 3,505 meter runway. Is that a large enough runway, sir?
Yes, yes. The runway length is good enough. There's no doubt on the 3.5 kilometers of runway.
It's one of the largest in the country.
Yes, yes.
So
yes.
this is not a tabletop. It was middle of the afternoon, bright sunshine. Clear flying conditions.
Perfect.
We are not talking about some weather, other kind of issue over here at all whatsoever.
No.
Now the crash site is 3.2 kilometers away. It's at the BJMC College. So the crash, sir, is in the almost direct orientation of the runway. It's not veered to the north, south, east or west. It's pretty much the direct orientation of the runway, only 3.2 kilometers down.
That's right.
So he's heading in the right direction, but has no power.
Has no power.
Okay. Now this is the breakdown of, this is published by Boeing. So this is Boeing's own breakdown. So what we've identified, sir, here is that we've identified this section, which is the tail section, and the horizontal stabilizer, which is part of the banged into the building.
Yes.
We don't know what happened to the vertical stabilizer. We haven't seen it.
It is there. It is there. Yes.
So I can't see it here.
No, in the previous slide.
Yeah, I don't know. I can't see it from the horizontal stabilizer. We can't see it. Maybe there. It may be there, but we can't. Vertical, the horizontal stabilizer is there for sure.
The rudder portion we can't see.
Yeah, we can't see. So we can't see, but we can see that this aft fuselage, this has got smashed into the building here.
Yes.
This is the aft fuselage right here. This here you can see is the aft fuselage. You can clearly see the tapering end of the aft fuselage. The tail is wedged separately. The aft fuselage is wedged separately. Then forward of the aft fuselage, which is the purple section over here. The rear part of that purple section you can see over here. Okay, which is the painted part.
Right.
And the front part where the wings are, which is where the fuel is carried,
yes,
is what's blown up. That had 9 hours of fuel.
Yes, 1.5 tons of fuel.
Yeah, maximum fuel load for an aircraft.
Yes.
Now here we know from what we got from flight radar that it hit a barometric altitude of only 625 feet.
That's right.
Given that 200 feet is the height of the airport, only 400 feet of height was gained.
That's it.
It had a rough duration of about 60 seconds. It hit a ground speed of 174 knots.
Okay.
from point of departure to the point of crash, roughly 60 seconds, sir. So
Right.
you can, but it hit a ground speed of 174 knots. That was the top speed. Now, what would you think of this figure? So 174 knots and 625 feet barometric altitude.
You see, what happens is during the takeoff, there are three stages. Number one stage is from the start, when the ATC allows you to take off. When you release the brake, open power and release the brakes, you go to a situation. First situation is go, no go.
Yeah.
That is the point where all the three wheels are firmly on the ground. Your speed has developed to an extent that now onwards you can take off. The aircraft can become airworthy, subject to other conditions. After that, next stage is rotate, that is V2. Rotate means when you lift your nose wheel. This means there is partial lift on the wings, and with that the aerofoil section, when you tilt, when you pull the stick back, your nose lifts up a little bit, very controlled. The next stage is unstick, when your main wheels leave the ground, when you unstick from the ground, when you leave the ground and get fully airborne. That is the time when the aircraft has developed full lift over the wings and it's now being sustained by the engine power.
Okay, so let's take it through. So he's taking off from the northern side of the runway, heading in this direction.
Right.
At some point of time, you hit V1.
That's right.
Okay, and V1 is your go no go, right?
Go no go.
That this is the last chance for you to abort the takeoff.
Yes.
At that point of time, the pilot is still comfortable that he has enough power or enough speed.
At that time, you are sure to be able to stop the aircraft
within the runway.
Within the length available.
Okay.
Runway length
so
available.
Somewhere down, which is maybe about halfway down or slightly
Yes.
more than, slightly less than that, you have V1, where at that point of time the pilots have made a decision that they have achieved sufficient ground velocity. They feel
the
confident.
engines are developing enough thrust.
Yes. So at that point of time they are confident. Then now at this point of time, after it is too late, they have no option. They have to attempt to pull the nose up because they will run out of
that's a
runway.
process. Yes, that's a process till you get that rotation speed, and thereafter you have to take off.
Okay, so what we do know is that it has taken off. It is not simply
It
barreled
has.
off the end of the runway.
No,
so
no,
it
no,
did
no.
take off. So it had enough lift and velocity to take off.
That's right.
But in the seconds after takeoff, so the engines were working. If he had lost one of the engines before V1, he would have aborted. If he lost one of the engines immediately, perhaps the reportage to the ATC would have happened immediately that I've lost an engine on takeoff.
Yes.
So it is not unusual to presume that at the point of takeoff he had both engines operating,
That's right.
and then something in the next few seconds catastrophic has gone wrong, and it is highly unusual if you lose power in both engines, because you mentioned one engine should have been enough.
That is a stage where at about 400 feet above ground level,
Yeah.
he has achieved that speed of 175 knots.
Yes. Correct.
Okay.
Yes.
Now that is the moment when he has lost the engine power, both
Yeah,
together.
that's the highest ground speed is achieved.
Okay.
At 174 knots.
That's the point where he has lost both the engine power, and the descent is started.
And because the height is only 600 feet, the descent, even though it's a
600 minus 200 elevation.
yeah, so 400 feet, nothing.
400 feet.
Nothing.
And from there onwards, he has to put his nose down initially,
Yeah.
and then when you're close to the ground, you take this position.
So he's tried to make the best of it, knowing what was coming, and in the few seconds.
There
he had.
is a doubt on the sabotage point of view.
I can't find any case history, sir, that is known to
How
us.
about
of both
Malaysian
engines.
Airlines? How about Malaysian Airlines?
We don't know, of course, what happened in the case of the one aircraft
That
that went
aircraft
missing.
got diverted from its route. How come? That was a hacking. You see, these days, these are computerized aircraft. They have high-tech computers which can be hacked.
Sir, I know we have to let you go, but I just want to take a couple of thoughts. double engine aircraft these days are designed, as you mentioned, to run on one engine. If he had lost one engine, which had flamed out for whatever reason, bird strike, could be anything, he would have had enough power to continue, circle and return.
Yes.
And then do
Yes.
an emergency landing.
Yes.
But it is an emergency landing, but it's not necessarily a catastrophic failure.
That's right.
To lose both engines is almost unheard of.
Unheard of, and suspicion is a sabotage. Please think of that. Let the authorities, let the cybercrime people also be involved in this investigation.
What would be the? To lose one engine is a very rare. I'm assuming
It happens.
is a very rare occurrence. But to lose both engines, which are two independently
Not heard
function,
of. Not heard of. Both engines together on takeoff.
to have a technical fault in both engines at the same time in the same place.
Not possible.
I won't say it's not possible, but it's it's 1 in a million, 1 in 2 million kind of
It's
thing.
possible because it has happened.
Yeah, well,
It is possible because it has happened once, but it is most improbable. We have to think of those lines.
okay.
too.
So last thought. Till V1, he has enough momentum. Okay, so and at some point of time beyond V1, he has managed to achieve takeoff. All three gears have left the ground. Then about 10 or 12, 15 seconds later, he is announcing to the ATC that there is a catastrophic failure.
Please remember one thing. At unstick, I don't know the exact configurations, but at unstick, this aircraft must have developed a speed of a little over 100 knots, 120 knots maybe. Okay. Thereafter, in a gradual climb till 400 feet above ground, he has gained another about 50 knots of
Yeah,
speed.
he's peaked at 175.
That is with power and climbing. You cannot achieve 175
And then it's just
and climbing.
and it's not weakened. It's just vanished. That the crash happened seconds later.
Power has
Suddenly stopped.
Yes.
On both engines.
both engines.
So he's got. You can tell from the visuals. Okay, as we've gone through it, and I'll leave you after this, sir. But you can tell from the visuals that he's got attitude control.
Well,
This is still
Pa-
a powerless but controlled glide.
you see, these are fly-by-wire. Power controls are depending upon the electrical supply. The batteries are still live. They run on the motors. Your controls run on motors.
Don't they have a rotor at the back that in case you lose engine power, the rotor drops to keep your fly-by-wire system
No,
running?
no.
Okay.
No.
The systems exist on some of the aircraft. I don't know whether it's
Fly-by-wire is a system where the wires connected to a motor. Motor rotates your
Correct.
flying controls.
Correct. There is a system available in these aircraft that if you do lose engine power, that they deploy basically something that utilizes the wind rotation to keep your critical systems going, so that you can control your electronic systems. I don't see that deployed here. So this is a person, the pilot, the cockpit still has attitude control. They are going into basically a controlled glide, and they're trying, as you mentioned, they're not trying to pull up at this stage. He is just hoping.
He cannot pull
because
up.
he's got no power.
He's got no power.
So what can you do in the 15 seconds that you have?
You see, the only thing as a pilot, if I would do, look for a safe landing place, that is an open field. Now here, there is a procedure where both end of the runways have to have a funnel, which is a safety funnel of 5 kilometers, about 5 kilometers, where there should be no construction. In this case, there is construction within that safety funnel.
Yeah, it's within 5 kilometers for sure. Okay, so just
3.2 kilometers.
Yeah, so just a last thought on this, sir, and I just want to quickly get your last thoughts on this. Is in the visual here, okay, and let's take it to the clearest shot that we have right here. I can't now. It's daytime. I can't necessarily see flames or smoke emanating from either of two engines. That doesn't mean that it's not on fire. Fire can happen and we simply can't see it. But I don't see smoke emanating from anywhere.
There is none.
Would it be I mean, if there was a fire in one or both engines, would the smoke be visible?
Absolutely, immediately. Immediately. It doesn't take time because the air flows so fast in the engine.
So you would see smoke
Immediately.
pouring out of the back.
Immediately.
And to have a bird hit in both engines simultaneously, is it?
Very, very rare possibility. Unless there's a huge big flock of birds.
No, because we don't see it. It could be, but in this we don't see it.
Don't forget the distance between the two engines. The distance between the two
Again, we're talking about 1 in 10 million kind of 1 in 20 million kind of very low odds of something like that happening. That you lose both your engines or a bird hit happens on both engines simultaneously.
There are aircraft who have run through a flock of birds and engines have flamed out. At the same time, they have had bird hit on the other parts of the body, like the nose of the aircraft also, but not on both the engines because they are well apart.
So, I mean, there would be almost 40-50 feet distance between the two engines on an aircraft of this size.
I guess so.
Yeah, of an aircraft of this size.
I guess.
Okay. Last quick question: what is the way to try to restart your engines if you have lost both of them?
You have to. There's a procedure. We call it relighting the engine. We relight the engine first with throttle back. Then procedure has to be followed. You relight and put the throttle on. Feed the fuel because relight means the fuel in the jet engine burns.
Yes.
Which provides thrust.
Yes.
And it's a simple principle. Air is sucked in, power is generated, and with force, the hot air is thrown out.
Yes.
That causes reaction and the aircraft flies. But in this case, now in case of fire, there would be immediate smoke trailing from
So
them.
it doesn't look like it.
It is not.
Okay, last question before I let you go, sir. In the 30-40 seconds he's got, the pilots have got, I mean, what could they no chance basically.
No chance.
If you have no power in both engines, it's game over.
You see, it's done. All that he has to do, the pilot has to do, is look for a safety zone.
Which of course wasn't there.
Which wasn't there.
He's done whatever. He's got his undercarriage deployed and he's tried to go into
and
landing
he has
position for the best.
and he has tried to make the landing as smooth as possible. That's why the structure is so much intact.
So he's basically tried to land the aircraft, only he
Yes.
landed into buildings.
Yes.
He's landing the aircraft here.
And there must have been a panic in the cockpit.
Of course.
There must have been panic.
And so you can see it.
I have seen experience, sir, when an emergency like this, I have gone through a couple of times, your hands go numb. You freeze for a moment, before you start to react. It happens. It's a very, very tense moment. It's a matter of life and death, not only yours, of 242 passengers plus crew. It's a very, very tense moment.
Yeah, but the basic summation is this does not look like that here is a pilot who's pressed a few wrong buttons and gone for a nap.
No, I don't.
He had no chance.
I would rule out.
The pilot had no chance.
Only after the engine power has failed that he has gone down. There was, I mean, if at all he has pressed a wrong button, where could he have pressed the wrong button?
Yeah, very good. So no, this is not one of those things that this was, it was flying at 40,000 feet and they were all taking a nap and something went wrong. It was no chance. There was nothing the pilot could do at that point of time. That's
he couldn't have done it.
Squadron Leader, thank you.
Thank you
Thanks for
very
taking us through
much.
this. Okay.